Hope you all are surviving the third day of Ignite and doing well and being healthy here. So first of all, thank you very much for showing up. I know you have a lot of sessions to go to, so thank you for choosing this session and coming here to learn about Windows software, defined data centers, and our hardware offers. So my name is Siddhartha Roy, and just a quick bit about me. I'm the Group PM Manager for the software-defined data center strategy. I also specifically look at software-defined storage and the high availability. I also work closely with the parallel teams on compute, network, and security. And along with me, I have Subodh Bhargava, who is leading the program. He'll be the one who'll be talking most in the session. So I'll do a bit of a quick intro.
Hey everyone, my name is Subodh Bhargav. I'm a program manager in Windows Server team, part of Sid's team here. And I'm going to be talking later in the presentation about the program and the offerings. So I'll pass it on to Sid for now.
Very good. So let's talk a bit about Windows Server 16 and software-defined. You probably heard a lot of things about Windows Server in the last couple of days. So just to do a quick recap, Windows Server really has, three broad areas that we have. One is, our security initiatives that we are doing not just on the host platform, but also in the guest. Things like, you must have heard about assurance with shielded VMs. And in the guest, you probably have heard about our just-in-time and just-enough administration efforts. And then the second piece is basically, what we call the software-defined compute, network, and storage, which is the core foundation of the host infrastructure for the data center. And then supporting that is cloud-ready app platform. Think of that as your application platform for developing new apps around Nano and containers, both Windows Server containers, Hyper-V containers, and deploying those apps with orchestration frameworks like Docker, Docker Swarm, Kubernetes, and others. So what we're going to focus on today is really the first couple of pillars, and really kind of explain to you what are the software assets that we have in Windows Server for the software-defined portfolio. And most importantly, what are the challenges we have in terms of kind of bringing that all together? So let me start a little bit about security. So one of the things we have done around security is introduce the notion of shielded VMs, which basically gives you hardware-rooted trust integrity in the host, in the sense that you can encap your VM and put a shield around it, and that shield is basically linked to the hardware TPM on the motherboard. So what that means is nobody can peek inside the VM unless you are the tenant owning the VM. So it gives kind of unprecedented levels of security, and we believe that this asset that we have compared to other software-defined infrastructure incumbents in the industry, and this is unique. Nobody else has this. So we believe that assurance is the cornerstone of our software-defined, which lets you really rest easy in terms of knowing that all your Hyper-V VMs, whether you're a enterprise or a service provider, nobody can crack that open, including if you have, in case some malicious admins, nobody can peek inside the VM. Unlike today, where you can crack that VM open pretty quickly. In software-defined compute network storage, let me kind of walk through quickly. In compute, that's basically Hyper-V. That's our core hypervisor platform. We have done a lot of things in Hyper-V since we started back in 2008 R2 R2 timeframe. I'm not going to go into all the major enhancement, but just touch on a couple of them. So a lot about the Hyper-V platform has been about how do you scale it, okay? And if you know, the same Hyper-V platform is also used internally in Azure. So you will see a lot of the scale design points of what we learned from Azure. We are going to bring that on premises. Not just scale, but also resiliency. So things we have done is, how do you make the VMs more highly available, and both to like compute failures and storage path failures, for example. We have done things like rolling upgrades, where you can upgrade the Hyper-V cluster, from 2012 R2 to 2016 in a mixed mode, where you can very easily embrace the latest OS. We heard you because early in the past it was very tough to upgrade to the latest OS. So then let's double click on a little bit on software-defined networking. Software-defined networking is really How do you abstract your physical network? Today, the physical network is very static. And how do you put network function virtualizations around routing, switching, your edge services, load balancer, firewall, all in software? And you can just-in-time provision the networks, including microsegmentation, network security groups for the different tiers of your apps, and really reconfigure and apply those policies on the fly, right? And then lastly, software-defined storage. A couple of quick shout-outs there is basically we have done this thing called Spaces Direct. We have shared Spaces in 2012. Spaces Direct really enables you to take advantage of servers, shared nothing architecture. So, and then we have things like Storage Replica, which gives you synchronous replication. This is all included in Windows Server 2016 Data Center Edition, so all inside the box, ready to go. So if you combine everything together, there's a lot of software bits coming in, right? And all these SDDC capabilities, as I said, we are bringing a lot of things from Azure scale and putting it in the box. Azure is really a hoster where the service provider maintaining Azure is Microsoft, right? And when we are bringing those on premises and packaging that up for traditional virtualization and private clouds, where SDDC is aimed for, we know that we need to kind of make sure everything is packaged up cleanly so that your customers, you or your customers, if you're a partner or a SI, can deliver this basically seamless day zero experience, right? So with that, I'm going to dwell a little bit on some of the challenges we have ahead of us. By the way, I gave the talk yesterday with a couple of my colleagues. I hope you caught that. We talked about the entire software-defined data center yesterday. So if you haven't, go and check that presentation out. It'll give you the complete outline of what SDDC is. So some of the key challenges in building SDDC, right? So SDDC is really software. What we are doing is working with our partners on enabling the volume x86 hardware roadmap. So we are taking the latest innovations in the x86 architecture, in devices, in NVMe, in storage class memory, the fastest interconnects with 10 gig, 40 gig, and going on to 100 gig in the future. And we are really putting software on top of hardware, right? So one of the main challenges there is design and integration. Based on our experiences internally, we can tell you that this is not easy to do. This is like difficult, It is not like you taking a bag of bits and just putting it on any server at scale on a 16-node hyperconverged server and kind of expecting that to work. It's not. So what we wanted to do is make sure we package those design and integration experiences that we have found out inside Microsoft working with our partner and not have you to go through the same pain points, right? So that was the first focus on design integration. The second thing is deploying the bits. In the software-defined industry in general, deploying the bits, although we have made it very easy, I talked about this yesterday, deploying like a cluster is very easy. There are still room for errors, right? So deployment is about making sure we have the right guardrails so that when you, as a partner or a SI, go to your customer, the day zero experience of deploying software-defined is very smooth, and your time to solution is really quick. You should not have to be there for a week and struggling with the customer, and the customer starts off with a bad experience. That's not the intent. And the goal is also to make sure that our software-defined plugs into their existing environment in terms of their Active Directory, their DHCP, their DNS, and not have to do something like a new, fresh forklift upgrade. We kind of work in both modes, what we call greenfield and brownfield. So that's deployment. And then once you deploy and bring this up, okay, once you bring up your software-defined compute network storage, you need to operate and manage that, right? That's where we basically are making sure that all your day 100 scenarios in terms of expanding the hyperconverged cluster or kind of bring things down for maintenance or servicing it, all that is, we are giving you the prescriptive guidance through our partners working with you to make sure that you have a clean experience in the operational management side of the house with System Center. Okay, so all these challenges essentially led us to define a program with our partners to make sure that we work very intentionally in all the stages and be very intentional so that jointly with our partner, we deliver to you, our customers, a very smooth day 0 and day 100 experience, okay? So with that, I'm going to be here available for questions. I'm going to hand off to Subodh. He's really driving and setting up the program with our partners, so take it off.
Thanks, Sid. Hello again. Welcome to the session. Sorry I didn't welcome you before. So yeah, I'm going to be talking about the program itself, which is Windows Server Software Defined. So there's two facets to this initiative, I should say. There's a program, and then there's, of course, the offerings, right, which are led by partners. I'm going to be talking about both, but let's start with the program. So just to frame what the program is all about, in a nutshell, right, so this is what this is, and each word is important here, so let me just stress on each and every one. Quickest, lowest risk, most cost-effective way for customers to consume Windows Server 2016 software-defined data center, right? Think about that for a minute. It's the quickest, lowest risk, and most cost-effective way. That's a pretty impressive claim, right? But let me tell you how we make that happen. How is it real? So what have we done to actually, realize that goal that we set out for ourselves, I would say about 6 or 7 months ago when we started on this program. So as Sid alluded to before, there are some key challenges with software-defined data center. And we took it upon ourselves to look at each one of them, which is design, which is the first one, where we work with hardware partners one-on-one, and the engagements have been going on with some of them for over a year now. And we make sure that they follow very prescriptive guidance, design principles, and best practices that we have embedded in the reference architecture. And this is key for the program because, again, as Sid alluded before, it's easy. I mean, in theory, software-defined is just supposed to work, right? I mean, you take any hardware off the shelf, you lay the software bits on it, and that's really the idea of software-defined data center. But in practice, what we have seen is, and this has been our experience, we have gathered over many years, I don't know, when we started the journey with storage spaces back in 2012, with software-defined storage, and then we added SDN to it, software-defined networking, then added some assurance pieces, compute was already there, Hyper-V, right? So this has been our learnings over last several years that also culminated in by the way, something called CPS, Cloud Platform System, that's available today, right? So it's an appliance that's branded by Microsoft. And we took all those learnings, and those have all went into the program in terms of design, which is the first thing where we work with partners in consultation with Microsoft. And then the solution vendors come in, the same partners, pretty much OEMs or service provider, SIs, and then they go through something called a validation phase for the hardware itself, right? And I'll talk about each one of these phases or pillars, if you will, later in the slide deck. Again, the idea behind validation, sorry to go back, is to really make sure that the design is perfect, right? You've got the design right. You've picked the right hardware for the right workload, right? Whether it's performance optimized, capacity optimized, or balanced. And I'll talk about that a little bit more. But it's also important to make sure that the devices and components used in these systems meet certain quality bar, right? Meet certain requirements. Now, most of these devices, as I said before, I mean, it's software-defined. They work with industry standard APIs, and they're just supposed to work. But again, in practice, what we have seen is it's important to stress test them. It's important to make sure that the guarantees are respected, right? So that software can rely on those guarantees and work on the software piece of it. So there's definitely a coupling that goes on with hardware, and it's really crucial to go through that step of validation, and that's a part of this program as well. In deployment, we make partners and customers' life easy by actually automating the entire end-to-end deployment. I have a very cool demo on one of the later slides that shows how it's done by partners. Just to stress on something here, right? Now we have reached to the customer aspect of things. This is really providing a sneak peek behind what goes on in the program, right? This is not, I mean, you, the audience, who are customers in the audience, right? For you, it's not for you to deal with all these things directly. This is just to give you an appreciation for what goes on, I mean, how the program works and how we work with our hardware partners to to make your life easy, right? To do all the heavy lifting that goes on in bringing these offerings to market. So as far as design, validation, deployment goes, it's really all partner-driven. The first phase is also Microsoft-driven somewhat, which is the design phase. But this last phase, which is really the operations, right? How do you operate and manage the stack? The onus lies on the customer, right? And for that, we recommend System Center, SCVMM to be more specific, and SCOM, System Center Virtual Machine Manager and Operations Manager, to manage and operate the stack on an ongoing basis, day 100 operations, as we call it. So again, all these phases are really important. It's not just enough to do a right design. It's not enough to pick the right parts and validate them. It's not enough to deploy it in the right manner, which is, by the way, where customers also falter a lot, right? So you have everything in place, but you just don't know how to deploy it, right? Because there's a sequence to these operations, especially in these complex layers that interact with each other, right? Software-defined storage, networking, compute, and assurance. So the deployment, the bare metal deployment has to be done in a certain manner, and I have a demo that shows that. And then finally, the operation, which is really up to the customer to do it on an ongoing basis. And again, just to stress on operations, I mean, without that, you cannot fully realize what SDDC has to offer. It has to just work seamlessly. It's not just enough to do the day one deployment and just leave customers stranded, right? So that's what the program entails. And I'll dive deep into each one of these areas later. But let's look at customer benefits, right? So that's all great about the program, but what that really translates to in terms of customers getting out of it, right? So what does that mean for customers? The first one, obviously, is choice of hardware. As you'll see later in the presentation, we are working with a bunch of hardware partners, so you don't have a few choices. You have many choices. You have many different configurations to choose from performance optimized, capacity optimized, or balanced, all flash, hybrid, and you name it, right? Hyper-converged or disaggregated. So that's great. The second one, obviously, is quality. As I mentioned before, the way the program works, quality is a cornerstone of the program, right? The key thing that partners have to do is make sure that the devices and components are certified and the solutions is validated, and the solution is validated end-to-end at min and max scale, right? And that's a tall order, and once they go through that, they get that stamp of approval, they get entry into the solutions catalog, and that's what quality means for end customers. So you're getting something which is highly reliable, highly stress-tested, and highly performant based on workload requirements. Accelerated time to value. This goes towards the deployment that I talked about before. So, we don't leave customers stranded. The box, the cluster doesn't drop at customer side and then you're hands off, right? There's a prescriptive way to deploy the stack, and by doing so, the time to value that a customer has, it really accelerates because, we're talking about going from days to hours, and as soon as the hardware lands at customer side, in a matter of a couple of hours, the stack should be up and running. I mean, that's the goal, and that's what we have tried to accomplish using automated scripting. It's all optimized out of the box. This goes towards the design phase as well as deployment phase. So the way the design works, the deployment works, it's very prescriptive in nature, and we have made sure that all the best practices are implemented in the way we like to see, like we as in Microsoft, right, working with hardware partner. So, needless to say that the stack is optimized out of the box day one. Now, of course, you're free to customize it to your heart's content if you want to, but we don't feel a need. We don't see it necessary for you to do that, right? So at least day one, you're up and running. Your time to value, you're optimized out of the box. And then finally, expedited problem resolution. And this goes towards the engagement, the tight engagement we have had with all our hardware partners. As I said, some of them going back almost a year now. And we pretty much have all their hardware in our labs sitting somewhere. And our engineers have actually worked on it. They have tested on it. They have tested our stack working with hardware, right? So what that leads us to a level of confidence that whenever issues arise, and they do arise from time to time, that Microsoft, working with hardware partner, can provide an expedited resolution to those issues. It is nothing contractual at this point, although we are trying to work towards that as well. But at this point, it's really a commitment and a confidence that goes on by working with hardware partners in a tight engagement and having their gear in our labs that, yeah, we can support any issues that arise at customer side because of these offerings. So those are the real key customer benefits. All right, so before we talk about the program offerings or the type of offerings in the program, it's important to understand the deployment options. There's a couple of ways to deploy the stack at the high level, and let me talk about that. So the first one is hyper-converged. It's really the buzzword these days, made very popular by some of the vendors that started to do this, I don't know, early 2011, 12. So it has been around for a while. With Windows Server 2016, software-defined storage, software-defined data center, we can offer a hyper-converged deployment option. There are sessions dedicated to talking about that. I'll point to those later on the slide. But with this deployment option, just to give you a high-level understanding of what it is, what you're doing is you're collapsing your compute and storage clusters on the same hardware node, right? So what you see here is your 4 servers, 4 typical x86 servers. You connect them through Ethernet, and you create a storage cluster as well as a compute Hyper-V cluster on the same node, right? So that becomes your hyper-converged deployment. This is good for customers who want that easy scalability. So this is really a data center in a box, if you will. So it's very easy to scale out. All you need to do is just keep adding these nodes, and each node brings with it compute, network, and storage all in one unit, right? So you scale in that fashion in lockstep on all three dimensions. It's also it's easy to scale. It's easy to manage just because of the same fact that it's hyper-converged, and all you're doing is for scaling out, just adding this one node, and it gets absorbed in the overall cluster, right? The software stack makes sure that whenever a node is added, the load is redistributed across all the nodes. The storage is redistributed. It's load balanced and what have you, right? So it's seamless scaling on a block-by-block basis. The other option is, if you missed that animation there, let me just play it again, because that's important to understand, right? So you see the storage components in the hyperconverged, right? If you take those out and put those in a separate cluster and then create a scale-out file server or a storage-only cluster out of it, right? So that offering in that orange box becomes your converged SDS, converged software-defined storage. By doing that, we are only leveraging software-defined storage in the stack. So we are not doing compute and assurance and SDN in this stack. But this is a very good alternative for traditional NAS and SAN arrays, right? So if you are customers, so customers today who are using traditional NAS and SAN arrays for their Hyper-V compute cluster, this could become a very quick and easy replacement of that storage with very low cost points. So it's not as sort of a forklift rip and replace, if you will, as you see on hyperconverged. Because in hyperconverged, if you have a compute cluster running, if you have workloads, you're trying to collapse those into the same cluster. So it is a little bit of a migration, if you will. But whereas in converged SDS, which is unique to Microsoft, by the way, right? No other hardware vendor today offers in software-defined infrastructure both these deployment options, right? They either do hyperconverged or they do disaggregated, but none of them do both. With Windows Server 2016, with Storage Spaces Direct, you can do either of those options that fits your needs. So the advantage here with converged SDS is really, as you can imagine, you can scale your compute and storage independently. So this is good for large enterprises and service providers who do not want to get locked down into that scale-out, scale unit model where you're scaling out compute, network, storage all at the same time, but you want to independently scale your compute and storage, right? So you have a Hyper-V cluster which is running some workloads, and you're happy with that, right? All you need is more IOPS. You need more storage performance out of that cluster, right? You can just scale the storage unit for that cluster, and that's how you do disaggregated. And that's the key advantage of doing disaggregated, which is another word for converged. It scales for larger deployments. So I hope that's clear. I'll pause for questions, I think, on next couple of slides, but and we can take questions then. So now let's look at the type of offerings that we do in the program. So we have talked about hyper-converged at a high level and converged SDS. So those are the two main categories of offerings. Within hyper-converged, there are two flavors, standard and premium. I'll start building the stack here, like what's included in these offerings, right? So everything is based on standard x86 servers, right? x86 hardware. So that's pretty much standard for all offerings. What you do is you layer storage, software-defined storage, which is provided by Storage Spaces Direct in case of Windows Server 2016. So that becomes your storage layer. For compute, it's Hyper-V. It only goes up to hyper-converged because, as I said, in disaggregated or in converged SDS, the compute cluster sits outside of the offering, right? So when you're looking at these offerings, they're either meant to provide storage only, which is converged SDS, or they're meant to provide a hyper-converged offering, which includes everything. Hope that's clear by now. And then for networking, again, everything includes the basic storage networking. So you have to do NIC teaming, for example, to make storage spaces direct work. So if you have multiple NICs, you have to team those NICs. You have to create a storage network, a high-performance SMB network, as I showed before, SMB fabric that it talks over. You have to do vSwitches and SMB direct, which is what I spoke about before. So there's some basic tenets of networking that are included in all three offerings. And then finally, there's security that comes as default in all three offerings, right? And then we'll see, which is Defender, CredGuard, and Device Guard. So as Sid alluded to before, there's a lot of goodness in Windows Server 2016 around security, which is, again, one of our true differentiators. And we wanted to make sure that when these offerings land in market, when it land at customer side, some of the security features are enabled by default, and they don't impact performance. They're just meant to help you create a very secured, highly secured multi-tenant environment. And again, this is one of the best practices that we have in design as well as deployment. So the deployment takes care of all of this automatically. Now to talk about what's the difference in premium, right? So I just added one block to premium, which is SDN. Again, Sid spoke about that before, software-defined networking. A lot of cool stuff in that stack, and we wanted to separate that out into a premium offering because there's a certain customer that looks for that in their environment, right? This is a customer that wants to do SDN, obviously, right? So they can get that. This is a customer that is trying to build a very secured multi-tenant environment, right? So most likely a hoster or a large enterprise with multiple departments, and you want to have secure isolation between these different tenants. And that's where SDN is really powerful. So we wanted to sort of separate that out into a separate offering, and that's why you see that. And then also for assurance, there's something called shielded VMs. Again, Sid alluded to that before, right? It's really to provide protection from malicious admins, the tenant VMs that are running in the host, or from a malicious, someone who wants to get access to your VMs, right? They cannot do that if your host guardian service does not allow you to do that for shielded VMs. So how do you shield these VMs? Again, goes towards building that highly secured multi-tenant environment at a customer side. So I'll just pause there for a second, just let you digest that, right? So basically, hyperconverged, converged SDS, those are the two main categories. Within hyperconverged, you have standard and premium. Now, the way we have created these categories, they are also meant to provide, they also impose some hardware requirements on devices and systems, right? So that was another reason for offering this distinction. So if a vendor is trying to certify and validate and bring to market an offering that is hyperconverged premium, for example, it will impose more hardware requirements. For example, you need support for VMMQ, right? So think about things that require, TPM 2.0 is required for shielded VMs to work properly, right? For SDN, you have certain hardware requirements that we ask you to fulfill in terms of device and components and systems. So you got to fulfill those. So basically what happens is the vendors have to choose whether they are trying to offer a standard offering or a premium. A premium can always work as standard as well, so you can do the validation for that. Or you're trying to build a storage-only offer, which is converged SDS. And we have different deployment options that cater to all these three categories, right? So again, the two distinctions are what type of hardware you're using for these offerings and how you're deploying the stack, and that's how you provide differentiation between these offerings. Now, just to be clear, it's the same license and pricing for all of them, so this is not meant to create any price differentiation or anything of that nature. This is more for the program itself, that how much validation you need to do, how much deployment of the stack you need to do, right? And what kind of parts you need to pick to create that offering. It has no impact on licensing or pricing. So, from a customer standpoint, everything costs the same in terms of, Windows Server Data Center SKU, which is the one SKU that we have for software-defined data center. So this is really cool. Everything is built into the OS. And then finally, System Center, VMM, and OM, as I mentioned before, that comes as part of all offerings. Comes as in, It is recommended as a tool of choice for operations and management. We also deploy it when we do the deployment. So we make sure if customer wants that, and we absolutely recommend that it's deployed by default. And that's how we make that happen. And again, these things are tested by partners, by Microsoft, the way the deployment works, and this is all prepackaged for you as a customer. All right, so let me pause there maybe for a minute or so and see if there's any questions so far.
Where would SQL clustering fall into that? Would it be a premium or standard?
Sorry, could you repeat that?
Where would SQL clustering fall under this application?
So this is all about infrastructure. We are not focused on workloads or tenants in this program or offerings. So this is meant to provide a hyper-converged or a disaggregated stack for customers. Once it's there, and as far as workloads go, right? So if you want to create a SQL cluster, that's all fair game. I mean, you can run VMs on it, which is the primary use case that we developed the stack for. So creating a private cloud. Or you can run workloads directly on CSVs. I mean, so anything is possible. We are not restricted to any particular workload. But to answer your question, SQL cluster is not part of, it is not part of deployment or validation or anything of that nature. It's all about infrastructure.
Just to add to that, I think you're asking about also SQL bare metal on storage spaces direct. If that's the case, then this is meant for the data center, for private cloud, which is Hyper-V centric. So this is all behind Hyper-V. So as SQL, as Subodh mentioned, you can run SQL 16 as a guest. For bare metal SQL deployment, that's something separate. You know, we are going to, as we announced yesterday with the SQL team, that kind of comes outside, but it borrows a lot of the principles in terms of the hardware profile and everything. And that's something we have certified with our SQL partners. We should chat offline about that program.
Yes.
Can you go to the previous slide? I have a question of what is the purpose of the physical server on the right-hand side? Does it converge? Do you have the server going over here?
Yes. So the idea behind the server is, I mean, you need a server for any of these offerings, and that's really what the partner offerings are, right? So yes, it's not meant for VMs. It's only meant to create a storage cluster, and pretty much what it does is it exposes a scale-out file server through SMB3 interface. Yeah.
My other question is if SDN is in the server code, right?
Yes.
Why isn't it in standard?
Oh, why?
So,
yeah.
Yeah, I mean, it is so. I mean, everything is in the server code, right? I mean, it's a single code base, single SKU even, right? So even from licensing pricing standpoint, it's exactly the same. Again, as I said, the idea behind creating these logical categories was really meant for our partners to be able to do certification and validation in a certain way, right? So as I said, for premium, you require a higher level of, you have a higher bar for certain components, especially like NICs, for example, right? You got to support VMMQ, RDMA is required. For BitLocker, you need TPM 2.0, right? So there are specific hardware requirements that are imposed because you are deploying SDN, because you are deploying shielded VMs, right? If you do not want to deploy that, you can create an offering that meets a standard bar, if you will, right? And still go to market and take that offering to customers. And also the deployment, right? So when we do the automated deployment of these stacks, we look at whether you're deploying a standard or a premium. If you're deploying premium, then we'll deploy SDN for you. Deploy as in we'll actually enable it and configure it for you, right? I mean, it's all built in the OS. I mean, it's all lit up anyways.
Think of, if I may just add to that, think of standard as just your pure play, hyperconverged storage and compute only. It doesn't have network. You as a customer, if you just need, your networking is outside of hyperconverged, you just need the benefits of hyperconverged storage and compute together. You don't need all the other software defined as yet, right? So that's the standard. And the premium brings in the additional SDN-centric pieces.
Sure.
The hardware itself, is it for 2 and 4 nodes always the same, or is it certified for 2 nodes, for 3 nodes, for 4 nodes?
Yeah, 4.
Yeah, so the device and the system certification is the same, whether it's 2 or 4 nodes. But when we do, I'll talk about validation a whole lot in the next few slides. For validation, it's really what the vendor wants to advertise, right? So if they want to advertise support from 2 to 16 nodes, which is the scale that we support today, right? They have to test at a 2-node min scale and a 16-node max scale. So there are some requirements around validation. But the system itself could be the same. Yes?
Who exactly does the certification? Is it you guys? Is it the hardware guys? Following your specification? How exactly does it work? I mean, who does the actual testing?
Yeah, actually, I have a lot of content on certification, so if you don't mind, we can cover that. I'll dive deeper into all these 4 areas: design, validate, deploy, and operate. Yes.
Just from my understanding, to be clear, is this a reference architecture? It doesn't sound like it is from what you're describing. Or is this a replacement for CPS standard and premium? Or is this something alongside that? And, what's the kind of, how are these things kind of supported? And you talk about it being a tested reference architecture. Does that mean that if a customer buys one of these, there's a continuous life cycle of testing, as firmware updates and everything else kind of changes? Or is it a point in time solution?
Can I take that?
Sure.
So,
Well, that was 3 questions.
yeah. I'll try to disambiguate that and answer one by one. So when we say the reference, this is not a doc we hand off to end customers and they put this together. That's not the intent. The audience of the reference architecture is strictly between Microsoft and the partner to share best practices. He's going to give you a view into what the reference architecture entails, right? In terms of positioning with CPS, I mean, this is not CPS. CPS is complete converged private cloud. This is aimed at your traditional word segments where you have your Hyper-V cluster today with your SAN storage. You're running out of SAN capacity. You have a choice of now, replacing that SAN or going hyper-converged. This is squarely aimed at, these offers are aimed at, how do you go and reinvigorate your Hyper-V departmental or enterprise, okay? If you need Azure consistency and with a complete private cloud, that's the Azure Stack solution, which is the follow-on to CPS. Now, having said that, some people might want to use this as a private cloud. It depends on the scale they want to use, but they will not get the Azure consistency pieces on top of this. Secondly, you talked about end customers will get offer. The offer means it's basically a hardware from the partner, okay? And the expectation is the partner goes to the customer site in the deployment phase, and there's a site survey involved and kind of, helps set that up. And once you're off and running in the steady state, we'll have best practices in terms of the day 100 scenarios like upgrading, adding a node. That's all through System Center.
It was more the kind of firmware, and you've got a kind of reference architecture. I mean,
Yeah.
As an example, firmware on the disk, storage space direct,
Yeah.
and the incompatibility that might coexist
Yep.
with what's in your reference architecture versus 12 months down the road.
Yeah.
Is this, will
That-
the OEM provide an update module,
Yeah.
on a quarterly, yearly, whatever it is basis?
So I think the OEM decides the firmware and the change management. We don't get into that, but we do provide the mechanisms of disk firmware update, dynamic firmware update through the health service. That's something new. You can go in and change a firmware on the fly, and Spaces Direct can understand that change underneath and roll with it.
More about it being supported, but
Yes.
Yeah.
Actually,
My
I
bottom.
guess you were saying, I got your question, Monty. If you certify once and then 100 days later, HP releases a new, for the same hardware, new firmware, you certify that new firmware. And you
Yeah.
tell the customer.
Yeah, so it depends. So that's a good question. So that's something we're working on with the partner, and depends on what defines the change. I mean, if we get into the business of managing every firmware update, think about it, like SAS expander changing, NIC changing, that'll be a very tedious thing, right? So something we are recommending to partners, if there's a fundamental form fit function change, if it's bringing a new functionality in the firmware, you rerun at least stress test with PCS and rerun parts of the life cycle. That's basically a quality statement based on our experiences when we have done this with CPS, which is Microsoft supported private cloud. That's something when we'll pass that experience on to the partner. But we don't want to get into the business of hand-holding and curating every firmware update. Microsoft doesn't do that. That's what partner does.
why build a solution, but you're doing that for Azure Stack, so why can't you?
This is not Azure Stack.
Oh, I know
So,
that, but you're doing that for Azure Stack, in terms of managing firmware and everything else.
Yes.
Why can't? You're in that business.
yes.
Why not?
No, this is not something Microsoft offers as a first-party supported product. Partners take this to market. The go-to-market is driven by partner field. This is not Microsoft delivering something as Microsoft branded. That's the fundamental difference. And the support of hardware is much more. If you see the variety of support of hardware.
Right.
I'm going to go ahead.
So with this, we are trying to reach a broader market, whereas with the Azure Stack and the appliances we have done in the past, it was very focused. So the feedback we received from the market was, I like this approach, but it only works for a certain set of customers. I mean, of course, there's a market for each segment, right? So the program is meant to cover more of a broad base, and this is more partner-led than Microsoft branded, right? So partner will take the ownership of curating the right firmwares for their customers and making sure that they go through the certification as and when necessary. So I'll just leave it at that. All right. So let's look at these 4 pillars one by one quickly. I think I'm running kind of late for this. All right, so it starts with a design overview, and I'll just give you a sense for, again, this is all behind the scenes look at how the architecture works, I mean, what the reference architecture entails, how do we work with partners, what kind of discussions we have. This is not for customer consumption, so you guys, customers in the audience, just make a note of that. I mean, there's a lot of complexity involved here, but if there's one takeaway from this session is, it will give you an appreciation for all the complexity, but we'll also tell you that we have hidden all of that. We have done the job easy for you. So working with hardware partners, right? To make sure that you don't have to deal with all these different things. But just to, again, give you an appreciation for what goes on. In the design, you'll look at hardware requirements. As I said before, there's a set of hardware requirements, very specific list for devices, components, and systems that we ask partners to go through the certification for. The server hardware, how do you configure server hardware? How much compute memory do you need? What kind of ratios you need to maintain between your cache and your actual persistent tier, right? How much memory do you need? What's the ratio between memory and the cache tier, for example, right? How much CPU is enough for any offering, right? Whether you're looking at performance optimized, capacity optimized, or a mixed I/O workload. Server and cluster configuration, what settings you need to enable in BIOS to make this optimized. Again, these are all optimizations and best practices. How to do cluster quorum, cluster networking. There's networking configuration that goes into NIC teaming. What are the different offloads that we expect the hardware to support? How do they, where do you require them, where you don't require them? For example, RDMA NICs, right? You don't always require RDMA, although we do recommend having RDMA because it has certain performance advantages. Storage configuration, how do you configure storage, starting from creating a single pool of storage, creating different tiers, doing different sorts of mirror parity or multi-resilient tiering, creating volumes from it then. What file system you should use, ReFS versus NTFS, for example, storage quas, how do you configure that, all that good stuff. Security, same thing. I mean, there's a bunch of things I showed on the previous slide around Defender, BitLocker, Credential Guard, Device Guard, Guarded Fabric. I mean, all of that is written in the reference architecture for partners in terms of how do you consume that, how do you deploy that for your end customers, and what do you need to take into account when building these offerings. System center configuration, same thing. So basically, if you look at the theme, let me just build this out, and design limits, right, finally. So what are the design limits? How far you can go, 16 nodes, 8 nodes, 2 nodes, right? So that's again all written up. How many volumes you can create, for example, right? How many disk devices you can use in a single pool? How much RAM do we consume? And I mean, what's the max on RAM? What's the min on RAM? And what are the mins on CPUs and things like that? So if you look at here, I mean, this is overwhelming, right? This is a lot of work, and that's why I said we have been engaged with these partners that you'll see later, over a pretty long time, just making sure that we provide them the right consultation to bring these offerings to the market, working with our software stack. But what it really boils down to is these few key things, right? So again, this is a discussion with partners, right? So we typically start with what type of market you're going after, right? What type of workloads do you want to host on these offerings? And based on that, whether it's transactional I/O workloads, like for example, databases, so you need a performance optimized configuration for that, right? Offering for that. You're looking to address a mixed I/O workload, which is a private cloud workload. You need a balanced offering for that, right? You need both cache capacity and a different set of characteristics. Or you're trying to cater a sequential I/O sort of a market, right? We are media streaming, for example, or doing backups, which is really streaming onto this compute cluster or a hyperconverged cluster. You need a different set of characteristics from the hardware, for that workload. So it all starts with workload and the type of market the partner is trying to go after. Then comes the offering, right? So, okay, you have decided on workloads. Do you want to put a hyper-converged form factor on this, or do you want to do a disaggregated or a converged SDS, right, as I spoke about before? And that plays into, how do your hardware BOM selection, what kind of parts you take to build these configurations, these offerings. So that's the next thing, right? How do you do BOM selection? So feeding into this, you will have a sense for workloads, you'll have a sense for type of offering, and then you decide, okay, for CPU memory, whether I need to do all flash or hybrid for storage. How many storage devices do I need? Do I need to fit it in a 1U form factor or a 2U or a 4U, right? I mean, how dense can I go? What are the price points I'm trying to meet, right? What kind of segment I'm going after? So again, that's dictated through these discussions, through the reference architecture when building these offerings. What kind of NIC even, right? You don't always need RDMA, as I said. You can do away with RDMA, for example, capacity optimized workloads. Configuration best practices, as I said before, what are the best practices around all these key areas, cluster, storage, networking, security, and system center, and then finally, our tools and guidance around performance, right? So how do you benchmark the system, right? Once it's out there, how do you provide your customers a sense for, how many IOPS it can run, right? I mean, how many VMs it can host? What's the VM density, for example? How much raw capacity versus usable it has, right? Based on how you have set your fault tolerance for different, for your configuration, right? And whether you are doing mirror or parity, the usable capacity would change based on the same raw capacity, right? So for that, we are designing tools, again, that we share with partners, and some of them are even public. For example, VM Fleet is an open source tool you can find on GitHub. And what it does is it orchestrates the VMs for you, and it runs an I/O workload called disk speed on each VM. And that gives you a measurement of performance in terms of how many IOPS you can drive out of each VM and how many VMs you can stand up on a cluster. So it's things like these, right? Again, this is just behind the scenes look at what goes on when having these discussions with partners. As a customer in the audience, again, I'll keep stressing that point. It's really just meant to give you an appreciation, not something that you have to deal with directly. And that's a good thing, right? Because it is overwhelming. Yeah. Capacity, we have a version available for, yeah, it is available for customers as well, yeah. I can provide you a pointer. We are still working through some of the nuances, but there's definitely a version that works, I want to say like 70, 80% accurate. All right. And again, to dig deeper into these topics, I'll keep pointing out to sessions that you should go attend or try to view them offline once they're available. So this one is really, really good one, and this one too for hyperconverged. All right, so let's talk about validate. There was a few questions before about validation, and hopefully these slides will answer those. So for validation, as I said, this is a cornerstone for the program. In fact, when we started on designing the program, this was the first thing that came to mind, and this was the first thing that we actually started working with partners on, because we know that it has a long lead time in terms of getting the right devices and components in the ecosystem and having those systems certified and go through the validation phase, right? So this was the first thing that we looked at, and it still holds prominence in the program in terms of how do you validate these offers, right? So let me start with the end point, right? Which is Windows Server software-defined WSSD offerings, right? So how do we end up there? So it all starts with components and system certification. That's the number one step for partners. They start with something called a Windows Server logo for all their devices, components, and systems that are used in the offering, right? For partners in the audience, they're very familiar with how Windows Server logo works, and it's a very known process. The key thing to note here is it is at component and system certification level, right? We haven't touched the solution yet. We haven't touched the entire end-to-end offering. The second step is that additional bar that I kept referring to, right? So again, this would start to make sense because we have created two AQs, or called additional qualifiers, right? The additional qualifiers map back to the offerings that I showed before, right? So there's a hyperconverged standard, and there's a hyperconverged premium, and there's storage only, right? Converged SDS. There are AQs that are designed to address each one of those categories, additional qualifiers as in. So what we ask vendors to do is, okay, you have tested your devices and components, they meet the Windows Server logo bar, right, which is the first one here. But we also want you to test and meet these certain specific hardware requirements for each component. For example, for NIC, you have to support RDMA, as I said before, for premium offering, right? There's some specific NIC requirements around VMQ, VMMQ, for example. There's specific security requirements around TPM 2.0 that are imposed on server hardware. How you set up UEFI and things like that. There are some switch requirements as well. So for all the devices and components that go into the offering, there's that higher bar that they have to meet, and we ask them to do that. Once they clear that, and then there's the final phase of offering validation. And this is really key because this is where we use, I have a follow-up slide on that something called Private Cloud Simulator, where we simulate a private cloud workload on the offering in a minimum and a maximum scale that gives us the assurance that, yeah, it can meet the demands of a real-world private cloud, a real-world customer environment who's trying to set up a private cloud. And what those tests do, I have a quick demo for that, and also I'll talk about that. But the idea is this, right? The idea is to really validate the offering as entire end-to-end solution, right? So far in the first block, what you see is just components and device certification, which is the bare minimum, but we also want to put everything together in a solution, in an offering, and then test it end-to-end in a scalable fashion. All right, so let's talk about Private Cloud Simulator, which fits in the offering validation, this yellow piece there. So Private Cloud Simulator, how this came about is also interesting. As I said before, we started on this journey of software-defined, 4 or 5 years ago. So we came out with storage spaces as our first software-defined storage technology, and then we have built on that and evolved that into something called Storage Spaces Direct, which is part of Windows Server 2016. And what we learned over time, and along the way, we brought out a couple of appliances, CPS Standard, CPS Premium, and we work with different partners on those. And this is really an accumulation of all those learnings in not only working with partners, but also with customers in terms of seeing some real-world issues, right? I mean, how the stack is impacted by different scenarios. And we have accumulated all of those into this test harness called Private Cloud Simulator, which is something we ask partners to test against. And it's a tool that partners use to validate their configuration end-to-end. And basically what it does is we start with service level agreements, right? So if you're building a private cloud, you got to meet certain, you got to be able to provide certain guarantees to your end customers, to your tenants, right? In terms of how much uptime you're seeking and what kind of workloads you're running and things like that, right? So everything boils down to how much availability, throughput, and scalability. What are those SLAs that you want to meet, right? Typically, we want to see 95% and above in terms of uptime and availability. But the point here is that you start with an SLA in mind, with a quality goal in mind, right? Then you look at private cloud scenarios, which are excellent uptime, as I alluded to before. How do you do load balancing when VMs move around across different hosts in the cluster? How do you do that? Non-disruptive admin activities, fault resiliency. These are all private cloud scenarios. Then there's private cloud simulation that goes in terms of we create a VM. We create a number of fixed size VMs across the cluster. We simulate a boot storm of these VMs. We move tenant workloads around. We do live migration of VMs. We do backup and restore planned and unplanned activities like someone tripped on the network cable. What happens then, right? Or your drive fails, your drive gets corrupted, your HBA fails, NIC fails. Things happen, right, in a private cloud environment. We want to test all those scenarios, try to capture as much of the real world scenarios as we can into these faults and actions that we do on the hardware. And then if that is not enough, we accelerate all of that and we simulate a year's worth of data center activity, right? So whatever I spoke about before, extrapolate that to over a year, right? I mean, what happens, I mean, how many operations, how many actions you can imagine, right, happening over a year, and we compress all of that into 96 hours, 4 days. And then the test runs for these 4 days. It tries to, I mean, it deploys these actions on different nodes, on different VMs, all the actions I spoke about before, and it tests the reliability and stress on the system. And the idea is that the solution should come out clear. There should not be any downtime on nodes. There should not be any tenant downtime. And that's how you pass that validation. And finally, there's a sign-off. So let me show you a real quick demo of this, how it works.
Is there a way to get a copy of that so we can run it on our
For what?
The simulator?
Simulator, yes. It's actually part of HLK, so anyone has access to it. You just need a certain level of, I mean, you of course need hardware to test it and certain level of expertise. Sorry, I missed a few steps. So this is showing you, how the tool looks like. This is our standard HLK. We have built all the test harness, all the test tools inside the HLK itself. So you start with creating a project. You pass it on to the test controller, and you start running these actions. So this is actually showing you what actions are being run. The first thing is to create 20 or 25 VMs per node, right? So there's a fixed number of VMs that I said before. As you can see here, the VMs are being created, and this is, I'm just going through different phases here. So pretty much 80 or 100 VMs are created for a 4-node cluster in this example, right? And once they are created, once all the actions are run on those VMs, the actions that I spoke about before, you can monitor the progress of those actions and those tests by going to a PCS report area. And you'll see here, you'll see one of the actions being performed, right? But over time, as we'll show you here, there's a VM clone action that you see here. I need a pointer. Sorry, let me just pause here real quick. I know it's hard to read, but I'll just give you a sense for what kind of actions are run, right? So there's a VM start workload action. So you start a VM workload. You live migrate a VM. You change the state of a VM going from start to pause. You simulate a storage failure. You simulate a disk failure. You power cycle a VM. You do VM clones. You restart a guest. You retire and repair disk. And what happens? How do you do RAID rebuild and things like that? So, I mean, suffice to say that there's tons of actions, again, as we captured over time. And this is a value that we provide to partners. It's available on HLK, and this is how we ask them to test their offerings to meet those quality goals that we had set out for them. And this is finally, you can see that actually on this screen, back to the same screen, here you see how many were successful and how many failed. So how many actions were failed and how many passed. And we want to see 90% and above pass rate in order to declare that test as passed. So that's the idea. All right. So that was the validate phase. In deployment, as I said before, this is led by the partner. We provide them that prescriptive guidance, the deployment scripting that they use to do the deployment. And the way it works is, we spoke about the different kind of offerings, right? If you marry those with, whether it's an existing infrastructure, existing customer infrastructure, or new infrastructure, right? Greenfield or a brownfield, as we call it, which means that whether you have existing Active Directory, DNS, and System Center, or you're trying to deploy, new Active Directory, DNS, and System Center, right? So if you combine those two, there are different combinations and different scenarios that these scripts cover, right? So hyperconverged standard, existing, premium, and new, and storage existing, storage new. You get the idea, right? So we cover all those scenarios. It all starts with a site survey. So a partner reps arrives at customer site. The hardware has already landed by then, and they do something called a site survey, right? So they check for all the prereqs for the offering to be deployed. For example, the top of rack switch, the networking is all in place. What kind of AD customer has, the AD credentials, gather all the networking information, how many nodes, and I'll go through a quick demo of that as well. And then you do the deployment, right? So it's a bare metal deployment. You're starting from scratch, like literally 4 nodes, 4 hardware nodes landing at customer site, and this deployment runs, and it takes about 1.5 to 2 hours, which is quite impressive. I mean, it's gone down from days to hours, going back to CPS days. So it's very impressive, and I have a quick demo to show that. And then all the stack is deployed for you. It's up and running, and within a couple of hours, you're hopefully done, right? So that's the deployment piece of the program. Let me run through this real quick, right? So this is how the experience looks like. So a partner would download the latest, greatest image from a Microsoft provided server, the image for the deployment itself, right? The image embeds a VL license, a VL image for the software, the OS itself, so that you don't have to worry about getting the latest image for the OS. And then, of course, it would be up to the customer to provide the VL license keys, or in case of OEMs, they can provide their own OEM license keys as well. We're trying to enable that scenario as well. So what happens here is in the first phase, you are creating something called a deployment VM. So you build a deployment VM, you pass the right parameters. Sorry, that was this phase. So you build a deployment VM, and you log into the deployment VM, which you see here, WSSD-SB-DVM. You log into this, and then you kick off the actual deployment scripting that will do the bare metal deployment for you. You pass all the parameters. It asks for things like your AD credentials, your company name, what's your Active Directory domain name. It asks for all the infrastructure, networking information. So for your bare metal credentials, BMC, BMC credentials, what's the local node admin password that you want to provide? A prefix for all the resources that will be set up in the cluster, a time zone, DNS. There are some optional parameters that are required only for SDN. So as I said, I mean, this demo actually covers hyperconverged standard deployment. So we are not going to worry about the premium parameters here. And then this is a brownfield deployment. I should have mentioned that. So we are expecting Active Directory already in place. So we'll just ask for that domain information and credentials. Now, as you can see here, it's setting up infrastructure domains for storage and SMB traffic and live migration traffic to flow. There's two VLANs, two networks that are created here, data network 1 and 2. Network services network, there's a transit network, and then internal virtualized networks and external networks. So all of this is done. Again, the idea is to not go through the mechanics itself, but just to give you a sense for, what do we ask for, what are the prereqs, and how does it all work? And then finally, the node information. So it's doing a 4-node deployment, so it will ask for parameters for those 4 nodes. What are the BMC IP addresses and the host IPs. So now you can see here the script has kicked off. As I said, it runs for 1.5 to 2 hours for a 4-node deployment, and I've just sort of time compressed this. But the key thing that goes on here is, it will join the DVM to a domain. It will set up a WDS, a Windows deployment server for you. It will do a bare metal PXE boot, install on all the 4 machines in a 4-node cluster. It will deploy, configure, and it will deploy, validate, and configure your storage cluster, then your compute cluster. Then it will go off and actually, as you can see here, let me just pause briefly. You can see that success message and QuickPath is a code name that we used for the scripting. So, and then finally you come to, and then by the way, it will deploy SCOM agents for you. Now you can see here, you go to VMM, you can see all the 4 nodes are healthy. And you can see all the, I think we skipped that, it was too fast. Yeah, this is showing you VMM. Let me just pause here. So you see all the 4 nodes are being shown here as part of the cluster. You can go in and check out one of these nodes, see what storage is available. This is all configured here. And then you can go to SCOM, and you can see all the management packs are installed properly. The nodes are healthy. So it has pretty much done an end-to-end deployment for you, right? And this is for a customer who already has SCVMM and SCOM. So all we ask for is provide us those parameters, and everything is onboarded onto SCVMM and SCOM. And that's the deployment for you, right? So it's pretty much started from a bare metal, deployed the storage cluster, deployed whatever it needs to deploy along the way to make that happen, right? Did the storage networking for you, onboarded everything onto SCVMM and SCOM finally, and this is the end state. So for PFC and DCB, it's not automated just yet, but we have documentation for that because that is too hard to manage. I mean, there's different flavors and different switch vendors you got to work with, so it's very hardware specific. But we do offer guidance on how to configure, I guess, the more popular switches, and that's where that's a prereq going into this. All right, finally, let's look at operate. I know I'm running really out of time here. I think it's 10 minutes, so let me just...
I think it should speed up.
Yeah, let me speed up because I do want to get to partner offerings, which is the key for this. So I won't dwell on this a lot, but suffice to say that we recommend SCVMM. It supports all the cool capabilities that Windows 16 has to offer. So it pretty much supports everything that's been added new to Windows Server 2016, including deploying storage spaces direct, managing your replicas, storage queues, doing a nano deployment, VM checkpoint, you name it, right? And I have a quick demo to showcase that as well. And same thing with SCOM. Let me move on to SCOM. It provides a single management. It provides a single pane of glass, as you guys know. Hopefully that provides nice visualizations and dashboard to manage your operations and to manage the operations of your software-defined data center. Again, it has plugged into health services as well, so now it can show you dashboards for storage health monitoring and reporting. So that's pretty cool. And again, you can check out this session to learn more. So let me do a quick demo of this. It will do a shielded VM creation, create port ACLs, bare metal deployment of nano server, storage queues, all very quickly, so don't worry about it. It's a very quick, it's a very quick demo because we are running out of time, and increase memory of a running VM, which is really cool, right? Which was added in 2016. So in a running VM, imagine, right? You can increase your memory, or you can change your NICs in a running VM, and that's possible in Windows Server 2016. So I thought that was pretty cool. So everything you can do through system through SCVMM. So let's look at that real quick.
Maybe
All right, guys,
let's maybe move on to the...
Yeah, let me skip this for now. All right, so partner offerings. So that was about the program. I'm sorry it took so long, but let's talk about the partner offerings. So who are the partners that we are working with today, and what offerings they plan to bring to market? So I think you can find your favorite OEM here. And again, I see you guys taking pictures, which is a great thing because you do want to follow up with these partners, whoever is your favorite OEM. And also visit their booth, by the way, right? I mean, most of them are here except for a couple. So definitely, I mean, they are the experts on their hardware, and they can help you understand what these configurations are and when are they going to be available, and what geographies and things like that, right? How to procure them, basically, right? So these are the partners, 12 of them. You can see the list here. And what we did was, just to sort of frame how these offerings are and how they have done the submissions is, we provided them with a single template, and you'll see a lot of things familiar here. So we started with a category of what offerings they are planning to bring to market, whether it's hyperconverged standard, premium, or converged SDS, whether it's hybrid or all flash, what's the scale that they want to advertise, 4 to 16 nodes or 2 to 8 or what have you, right? And that has to map with what the actual testing has been done, right? So the validation happens behind the scenes, and we make sure that they adhere to those validation requirements. What's the SKU name? What's the form factor? 2U, 1U, 4U, right? I mean, 2U, 4 nodes maybe. CPU, HPA, this is all self-explanatory. And finally, what are the tiers, right? So what's your cache tier? What kind of storage devices you are using? And again, for capacity, what storage devices and how many of them you're using? And if you have a third tier. So real quick, this is a template. And let's move on to the partner offerings themselves, right? So I'll start with Cisco. As I said before, it's really alphabetical, so no favoritism from Microsoft here. It's I've just tagged them in an alphabetical order. And I'll quickly go through these to give you a sense for what their true differentiators are. I'm not going to talk about all the details, speeds and feeds about the configuration. Again, it's a standard format, and the slides will be available for you for reference, but I've also pointed out where the booth location is. So the booth number is shown there on the top left. So please go visit their booth to learn more about these offerings. But let me go through these quickly. So Cisco is bringing their very popular C240 into the program. They plan to do hyperconverged standard, and it really comes in 2 flavors: a small form factor, as you can see here, and a large form factor, which refers to the small for 2.5-inch drives or 3.5-inch, right? So you can have 24 of them in a small form factor chassis, or you can do 12 of them in a large form factor. Again, the name doesn't need any introduction, so they pretty much provide all end-to-end services and deployment offers that you can imagine. I mean, Cisco is a big name. The next one is Data On. The key thing here is they're exclusively focused on Microsoft. They showed some of the performance numbers with the first config SD3110, 2.4 million IOPS using VM Fleet in a 4-node configuration. So that's truly impressive. The key thing here is they are all flash NVMe offerings, as you can see here. So really focus on performance. They do have a high capacity one in the middle here. Sorry, the one in the end, which really packs like 16 drives in a 1U form factor. So that's pretty impressive. Again, their booth is 2052, and
let's move on to the
Data On, the leading provider of hyperconverged cluster appliances for Microsoft Windows environments. Welcome.
Sorry, this is a quick customer testimonial.
So do we have time?
Yeah, let me play it like for 5 seconds just to give them a sense.
Microsoft Ignite 2016. Data On and Microsoft are pleased to introduce a new member to the TAP program, EVGA. EVGA provides the gaming community with the most extreme and realistic graphic experience.
EVGA was founded a little over 17 years ago here in Southern California with a plan to sell graphics cards, build a PC community, and bridge the gap between technology providers and gamers through our services. EVGA is known for its customer service in the PC hardware industry. Planning our operation with the latest hardware and software is very important. Our customers' technology at an affordable cost.
EVGA's corporate mission is...
I'm sorry, guys, I don't want to go over, and I see there's only like 2 minutes left here, and I have to cover a bunch of partners, so let me skip that. Again, this is all available for offline viewing for your reference, so yes. The next one is Dell. The name doesn't need any introduction. They're bringing the very popular 730XD platform into the program. This is something that we have hammered on within Microsoft Labs as well, and a lot of TAP customers have given a lot of good feedback on these. So again, it has already been through. It's a proven platform at this point. And again, as I said with Dell, I mean, you cannot go wrong. It's a one-stop shop really for all your end-to-end services. And again, a very, very good brand name here. Fujitsu, again, a company, they're the 5th largest IT service enterprises with 160,000 employees. I mean, I didn't know that until I wrote that line in my slide. So that's pretty impressive. So the very large company, mostly focused in APJ, but of course have a strong presence in EMEA as well. And they are doing hyperconverged premium offerings, both of them based on their Primergy PrimeFlex platform, RX2540M2. HP, bringing their DL380 Gen 9. I think the first thing says it all, world's best-selling server. So, you can't go wrong with that. They have their remote server management with, HP ILO and hyperconverged compute and storage. This is really interesting, 60 terabyte per node capacity storage in this 2U form factor. So they are bringing a very balanced offering, especially geared towards private cloud workload, mixed IO workloads. And that's that. Inspur, one of the top 5 largest server manufacturers in the world. Again, I didn't realize that until I actually wrote it. I mean, some of these names are not that known because they really cater towards they sell to hyperscalers. I think Inspur is one of them. As you can see here, they primarily sell to Baidu and Alibaba. And these are hyperscalers. So what they're trying to do is they're trying to bring those design points into a more enterprise market, into a more service provider market. Based out of China, one of the key strategic partners of Microsoft in China, and they are putting through their NFS 166M4 and NFS 5280M4 offerings. I think one of the interesting things here is 166M4 has the same storage density as 280M4, which you see here. So this 1U packs the same storage as this 2U, go figure. So that's pretty impressive. Intel, of course, a long-standing partnership with Microsoft. We not only work with Intel very tightly with their co-engineering efforts, right, in terms of optimizing their components on Windows Server OS, but we are also working now with their PCSD division, which is their white box division that mostly sell through the channel, right? So the channel has the opportunity to rebrand the systems and sell it to the end customers, provide support, and what have you. And as part of that initiative, they are bringing 5 PCSD offerings, again, sold through the channel that you can see here, going all the way from a capacity-optimized workload to a very performance-driven workload. Some of the all-flash systems as well as hybrid, as you can see here. Again, there's a lot of details on these slides, really for your offline consumption. But I'll just leave it at that. Again, please go visit their booth. We are also showcasing them in our booth. Oh, sorry, I forgot to mention that for Dell as well. So Dell, Lenovo, Intel, and HP are also showcased in the Microsoft booth area, so you can visit them there as well, in addition to their own booths, which I pointed out on the slide. So booth number 639 in this case. Lenovo, again, the same thing, a very good brand name in x86 servers. They pride themselves on reliability, always are at the top of the chart in terms of server reliability for their hardware. And they are bringing 3 offerings based on X3650M5 that go from, and all 3 premium, by the way, they go from, again, capacity optimized to very performance optimized. So you get a range of workloads to choose from to host it on. NEC, again, a very, very known name, especially in APJ. They are all about bringing your TCO down, so lower power consumption, complete remote manageability, and cooling and all that good stuff, right, from a hardware standpoint. They are bringing their 2 offers based on, sorry, I'm missing the server name. Yeah, the NEC Express 5800. So there are 2 configurations that it goes in. One is shown on the left as a standard, and the other one is a storage only, which is interesting. All right, so that's Quanta. Again, they go from performance optimized to capacity. So as you can see here, there's a common theme here, right? Their partners are trying to bring hyperconverged standard and premium offerings, most likely. Some of them have storage as well. And they are focused on bringing a range of offers that are performance optimized all the way to capacity optimized. And they have different configurations that you can choose from. So I think that's really the bottom line.
Let's wrap it up.
Yeah, and then Raid Inc., again, showcased as part of Lenovo booth because they work closely with Lenovo on this. And they work with one of their partners called ClearPoint that provides managed services for private cloud environments. So please go check them out at the Lenovo booth or at the Microsoft booth under the Lenovo banner. Supermicro, last but not the least, again, very popular especially with hyperconverged offerings and deployments in the market. They provide a range of offerings, as you can see here, again, going from very performance-oriented to capacity-oriented. This last one here is very interesting in terms of the density that it brings, right? It's a 4U unit with 60 drives, 48, 10, and 2, which packs like 9.6 petabytes in 16 node clusters. So that's pretty amazing, especially for a capacity optimized workload for backup, archival, you name it. With this one offering, 3011 Flash, they recently showcased, working with Intel, a very cool performance number, which is, so that's a good segue actually. So let me just leave you here with maybe this one. So they showcased 3 million IOPS on storage spaces direct, 4-node hyperconverged. This is a quick demo of that. As you can see here, there's 4 nodes in the cluster. You can see the disks are all CSVs, so we are running it in hyperconverge using local CSVs. And they stood up, I think, 20 VMs per node or 25 VMs per node. And they hammered, and they ran using VM Fleet, right, as I said before. And they ran disk speed at 4K, 100% random reads. And as you can see here, it drove 3 million IOPS out of 4 nodes. I mean, that is unheard of, right? So just take a minute to think about that. I mean, this used to be available only in high-performance computing areas before, which is really now democratized using storage spaces direct through Microsoft. So this is truly impressive. But wait, there's more. So as I said, I mean, that was just one demo, but actually, we also demonstrated 6 million IOPS over 16 nodes in the keynote on Monday, earlier this week. And 80 gigabytes, that is not gigabits, right? So it shows you the data movement. 80 gigabytes per second of bandwidth in a 4-node cluster at the All-Flash Summit in August 2016. And finally, 150 gigabytes. I mean, the number keeps getting more and more incredible, right? So whenever we achieve these milestones, we stop and think about it. It's like, whoa, that's amazing, right? And then 1 month down the line, some other vendor comes in and they try to prove their hardware. In this case, Mellanox is doing it. I provide the references to their PRs. And they're just trying to prove their 100 gigi cards, right? And the point here is that all these vendors, when they're trying to showcase their hardware devices, they pick storage spaces direct as their software-defined storage to showcase that, right? That tells you something. I mean, they don't pick anything else. They use storage spaces direct because they know that in this stack, we don't block them anything on, I mean, we don't block them on performance, right? Software is not the bottleneck in this stack. If you are willing to invest in the hardware like 100 gigi RDMA, NVMEs, right? You can really get the full potential from the stack, and we don't stop you from doing that. So that's really the point here. And the numbers will keep going up, but these are just some showcases that we have done more recently. I'm sure there's more to come up. So with that, let me just quickly conclude. Just with a quick recap, we looked at the program, we looked at the 4 pillars, how we do design, validation, deployment, and operation of the program, operation of the offerings, I should say. What are the benefits for the customer in terms of hardware choice, quality, time to value, optimization out of the box, and problem resolution. And finally, who are the partners that are currently in the pipeline who are bringing their offerings to market? So thank you so much for your time today. I'm sorry, I think I went a little bit over, but still, again, thank you so much for your time, and hopefully this was helpful for you. Please do give feedback. Thanks. Oh, and this is where the partners are located. I'll just leave it there.